At a quick glance, there's not a ton going on in downtown Finlayson, but tucked away in an old building in this small Minnesota town is a company using some high-tech equipment to change the way outdoors enthusiasts deal with the sun.
RLVNT is a company for outdoor enthusiasts. We say that we exist to give enthusiasts the edge. So we're trying to take some of maybe our technology or know-how that we've gained through the years in my other company, Quantum Innovations, and bring some of that technological know-how to the outdoor space. We've got a lot of different products from our bait box, which is this small little ice fishing box to hold your stuff made out of locally harvested wood, all the way to, on the high-tech end, our glasses, our stealth screen, our lures, and everything that we do on that end is somehow related to light.
Could you just not afford vowels, or?
Well, I wanted to say that the product, no matter what product we came up with, just kind of as a mantra, that it needed to be relevant all the time. When I went to get that name, relevant was already taken. So if I took the vowels out, I could do it. So I decided to make it an acronym, solving real life vexes with new technology.
So I think the first time I heard of Relevant, it was your sunglasses. That was the first product that I saw. Mm-hmm. So what makes your sunglasses special, and why don't you show me how you make them too?
There's a lot of different things that make our glasses special. So one of the things is we want the lens to be as clear as possible. So there's a few different lenses that have the same optical clarity as the lens in your eye. And so the lens that we're choosing is one of those lenses that's really, really clear. It's called Trivex. So the nice thing about Trivex is it's really clear, but it also gives you impact resistance. And then the other thing that we want to do is we want you to be able to see your screen all the time. So we have what's called screen view. So in order to do that, we've got a special polarizer, and then we also have what's called a photochromic. So a photochromic means that it's going to absorb light, and then it's going to darken up. And ours, we call it a chameleon because it also changes colors. This is our hunting lens, and this is a UV light. So it's kind of a greenish color. When we hit it with the UV light, it is gonna darken up and it's gonna change colors.
Oh, wow.
So when it darkens up, you can see it changed color. So the chameleon lens will darken up based on the lighting conditions that we're in. The other really great thing about this particular one is that we have two photochromics on this lens, one that's in the visible range, one that's in the UV range. And so that means when you're driving down the road, it'll darken up behind the windshield, which is unique to this particular product.
Oh, wow. I don't know if it's a blue eyes type of situation or what, but I'll wear sunglasses on cloudy days a lot of times. But also as a pheasant hunter, somebody that likes to wear glasses when I'm walking through, thick, heavy cover. But as the sun gets lower and I'm hunting later in the day, I want to keep that eye protection on without having to change glasses and things like that. So they'll lighten up as well. Yeah,
that's a really great thing. Is you can get in the duck blind when it's not quite light. You can be in late at night, and because of that, it's going to lighten up, and you're going to get it in its relaxed state like it is now. Or the sun comes up, and then it's going to darken and give you that sunglass experience. In fishing situations, we're going to go, like around here, there's a lot of iron-rich water, so there's a lot of reds in the water. So what we want to do is we want to turn down the color red, but we want to pass all the other colors. So what that contrast experience will be is that you can see deeper in the water, and you can see structure, you can see fish holding behind a log, you can see a lot of things. So what we're doing is, instead of having broad mirrors that just really they just look pretty, ours are functional.
Let's go see how you make these. Watch your step. So what's going on here?
So what we're gonna do when we're making a lens is we start with a raw blank. And this is a lens blank with nothing on it, nothing's been done to it. And the very first thing that we're gonna do is we're gonna clean this lens. So this is an aqueous cleaning systems, and the lenses are all gonna be cleaned on this side. And on the other side, it is going to be lacquered because it is really impact resistant, but we want to make it really scratch resistant as well. So what we're going to do is we're going to put a titanium nanoparticle infused lacquer in here that gives it a lot of abrasion resistance. And then we have to go into this other room, and then we're going to cure this lens, and then we're going to put a thin film coating on it. So this is actually a vacuum coating machine. We're going to vapor apply thin films. So the inside of this stainless steel chamber is going to get to negative pressures like space. There's an electron beam gun here. So this is actually a pill of zirconium dioxide that has been melted. We're going to get this to its boiling point. The vapor goes everywhere inside the chamber, and the lenses are spinning inside that vapor plume. And we put a layer of metal, and then we put a layer of glass, and then we put a layer of metal so that we can bend light in the way that we want to bend it. So this is a thin film vapor deposition system. It's a vacuum system just like the other one. This one's just much smaller. We actually make this at Quantum, our other company in Oregon. What I wanted to demonstrate is actually putting a coating on so you can actually see what's going on inside the vacuum. This is a nice machine for that. So I'm gonna load a lens and choose a process. So the lens goes on what we call the in-feed, and then it's gonna come up and say, hey, what do you wanna do with that lens? And I'm gonna choose maybe a rose gold coating and choose the lens size, and then it's gonna measure that lens, and then it's gonna roll that lens into the vacuum chamber. And what you're gonna see is you're gonna see different colors of plasma inside there. So we're using a different technique than that in the other room, but similar in the fact that we're thin film depositing in here as well. So this is going to create plasma based on the gases that are inside that chamber. There's your plasma.
So after they come out of that machine over there, what happens next?
So it's gonna come out. It's got the coatings on both sides of the lens. And then what we're gonna do is we've got to take this lens now and we've got to put it into the frame. So what we do is we come in this room, and then we're going to use this machine, and this is going to have a multi-axis cutter in here. So we're going to take this lens that's this shape, and then we're going to turn it into lenses that look like this. This is the old Muni here in Finlayson, Minnesota, and the other side of our building is the old fire hall. So we repurposed this space and turn it into a pretty high-tech thing for this area. And hopefully, not only do we create those jobs, but we give an avenue for young people that are passionate about something, maybe technology, engineering, that sort of stuff. They don't have to leave. They can stay here and have something high-tech in the area. You know, I graduated with 81 people. I didn't know what to do after high school, so I went into the military. When I went into the Navy, I chose the electronics program. And when I got out, I went to work for a company that makes thin film coating machines. And I left that company in 2002 and started my own company.
So you never went to college?
No, I never went to college. No, I don't actually have a formal degree in anything. It's just a confluence of things. That's the way life is. Once I understood that a lot of duck hunters don't know how ducks see or what causes them to flare, we contacted people that work in universities, some doctors, engineers, that sort of stuff that understand ducks and then turkey and deer, and then started to try and create some experiments to really understand how we could influence the vision of ducks. And then I invented a coating that make sure that the duck hunter's glasses won't be seen by the duck. So the stealth screen is something that kind of went along with that, which is, hey, if the number one problem that a duck hunter is going to face trying to conceal themselves is the fact that a duck can see perfectly in the UV, then we ought to do some things to conceal that, the duck hunter. So we messed around with a bunch of different products to try and get something that was going to block 100% of the UV, and by block I mean it's absorbing 100% of the UV, so that you can put it on your face and you look totally normal to any other human, but when you look at it on the screen with a UV camera and a UV light, you're going to see that all the light is gone. Always makes me laugh. So you can see me in the screen where my nose is completely black. It's really funny when you do your teeth or something like that. And then you could, if you look at me, it doesn't look like well, maybe it does. I can't see it. So.
Pretty heavy coating. But yeah, you work it in and it'll disappear.
Yep.
So for the guys that don't want to put on the black face paint,
yep.
You can put this on and have the same effect, yet it's completely clear to see on the skin.
Wow. Now I look real nice. When you see our lenses, they're completely gone to the animal. So when you see the combination, the concealment technology with the cell screen, and that's the benefit that you get when you don't have any reflection, any UV reflection going back to the animal.
So is that work as a sunscreen as well too?
Yes. Telling people that it works is the harder part. We can't talk to a duck, and so the duck's not going to tell us, yeah, I see you.
So after the sunglasses, you decided to get into the lure coating business.
Yep.
What do you hope to accomplish with that, and how does that work?
Well, hopefully we create a new category of lures. The thing that I don't think anybody's really concentrating on is the way that fish see and stimulating them to bite based on the way that they see. And then there's so much science that's been emerging around the way that predator fish see. A lot of predator fish are going to go and hunt using either UV or infrared, depending on the lighting conditions. And so what we want to do is we want to use those to our advantage to reflect back in a natural way to the fish. And then what we're doing in the visible range, because all the ones we made originally had no color in the visible range, and we were catching a lot of fish, but the fishermen were going, I don't even know why.
Right.
So we started adding color, but we did that in a way that is consistent with a scale or with a prey fish, so that way the fish is going to see something that looks natural to them.
We're talking about jigs, crankbaits, a number of different styles of lures, and currently you're working with other lure manufacturers.
I had no intention of actually selling a lure. I just had the technology and I wanted to do it for other people. But because every time I went and I talked to somebody, they had the same kind of questions that you have. Well, I can't see it. How do I know it's going to work?
Right.
And so I just started with making some of the basic products. What I'd rather do is put it on somebody else's lure, because we're not in the business of making lures. We're in the business of making the coating that needs to go on a lure. We're using thin film coatings. We're just going to bend light. In this case, we want to somehow create an environment where the fish is gonna want to bite. So what we're doing is we're bending light in a different way, but we're still bending light. We're gonna use the same devices. We are seeing what the fish is gonna see when this thing is going through the water, is that we are reflecting UV light. So when we talk about the fact that we are reflecting in the UV, this is what we're talking about. And this is just a normal crankbait. And I don't know who made this one, but you can see it's a traditional paint on there. But this is what causes so much fish bites, is because we're reflecting so well. We're trying to solve a problem first. That's just the way I see business. That's the way I see the world, is if there's a problem, we need to solve it. So we're doing the same thing at Relevant.